Okay, so in this lesson, we're doing miscellaneous triangle problems, and that might feel a little bit to you like it's revision, but it's really not. The key skill here is identifying a way of solving the problem. Often with maths, we have a situation where we set you a whole bunch of questions based on the little bit of information that we gave you today. In order to be able to do trigonometry well, we need to be able to identify which method to use to solve a problem, and also to understand that sometimes there's more than one way of going about things. So the key is to find, I guess, the simplest method, but it's okay if you find a more complex method as long as it's correct. So in order to solve these sorts of problems, you're going to need some sort of combination of Pythagoras, right-angled triangle trigonometry, the sine rule, the cosine rule, or area of a triangle formula. And you're probably going to need to have a little understanding of bearings or angles of elevation and depression in order to understand the question. So with that in mind, let's look at this first example. So we've got an area of a triangle is 250 centimeters squared, and we want to find the value of x just here. What is that value there? Now, one of the tricks that's here is that number 250 centimeters squared isn't on our drawing at all, and so it can be forgotten a bit easier when you're looking at the question. So I would be tempted just to maybe write that in the middle of the triangle. So I know that the area of that triangle is 250 centimeters squared, and that's going to give me a bit of a clue about how to solve it. There is more than one way to solve this particular one. It would take a little bit of time, but you could use two applications of the sine rule, because I've got an angle and I've got a matching side, and I've got another side distance, but I don't know the angle. So I could certainly work out that angle, and then I could work out the other angle in the triangle, and then I could use the sine rule again. But that seems to be a little bit of a waste of time in this particular instance, because what I'm thinking actually is if I use the area formula, for the area formula, I need an angle and its two included sides to find the area, which in this case I already know. So if we write out that area formula, the area formula is area is a half AB sine C. Now in this particular case, 44 degrees, that's going to be our C. So let's just substitute in the formula. Now we know the area that was given in the question, that's 250, times a half times 30 times x, that's the bit we don't know, times sine C, which is 44 degrees. So what I've got there is a whole bunch of numbers and one variable, so I should be able to solve for that one variable. So I'm just going to tidy that up a little bit. I'll go 250, well, 15 times by a half, 30 times by a half is 15. So I'm going to go 15x sine 44. And if I divide both sides of this equation by 15 sine 44, that means that and that are going to cancel out with that. And I'll be just left with x on that side, so that seems to make sense to me. But of course, whatever I do to one side, I have to do to the other. So we divide that side by 15 sine 44 degrees. And so we end up with a situation where I'll just change the sides around to x equals 250 on 15 sine 44 degrees. And now I can just plug that into my calculator and come up with an answer. So 250 divided by 15 sine 44, and I get 23.99. I think the question said to the nearest whole number, 23.99. I think that's pretty close to 24. And my answer is in centimetres. Okay, like I said, you could have solved that a different way, but I reckon that's probably the simplest way to solve that one. Okay, moving along to our next one, we've got a two triangle problem, and we've got an angle of depression. Now, we know that an angle of depression equals the angle of elevation. So this little angle in here is 75 degrees. But that doesn't help me much, because what they actually want to know is the angle of elevation from M to K. So what's actually wanted to be known is this angle in here. So I'll just put that little green line underneath it. So I know that that whole angle in that bigger triangle is 75 degrees, but I don't know what that little angle there is. So what I could do is I could think about, well, I can't see anything. There's no measurements. This right angle triangle down the bottom here doesn't seem to have anything of any value for me as far as helping me find out what I need to know. But there's a little bit more information provided in the top triangle. So if I found out what this angle was in here, then that would mean I could take that away from 75 and that would give me an answer. Now in this particular triangle, this angle is opposite that distance, and this distance here is opposite that angle, which I should be able to work out because this up here would be a 90-degree angle. So this spot up here is 90 minus 75. So let's just write a bit of that down. So I might say in triangle MJK, angle MJK equals 90 minus 75, which is 15 degrees. Okay, once I know that, I could use the sine rule. So what am I solving for? I'm solving for sine of m. So what I'm saying is sine m over m equals, my other angle is angle J, so sine J over J. So then I just substitute in everything. Now I put sine m at the top on the left-hand side because that's the bit I don't know. But the side opposite angle m is 20 meters long, so that's a 20. And then sine J is 15 degrees, so that's going to be sine of 15 degrees equals the length of J, the angle opposite that is 18 meters, sorry, the side opposite that is 18 meters. So I've got that information there. Now I'm going to multiply both sides by 20. Why did I choose 20? Because I want to cancel those two out. And I'm going to be left with sine m equals 20 times by sine 15 degrees over 18. I'll put that into my calculator. So we'll make a fraction 20 times by sine 15 degrees divided by 18. So that's going to give me 0.287 dot dot dot. Just to explain what I'm doing with the dot dot dots there, I'm just taking the first few digits off the calculator. I'm not rounding or anything. I'm just saying, look, there's more in the calculator. I'm just not going to write it all down here. So m is obviously sine of the minus 1. If we're finding an angle, we use that sine of the minus 1 or cos or tan to the minus 1 function. And it's going to be of that decimal we just worked out. So remember, for these, we go shift and then sine, and then we use the answer key. And that will give us 16.71. What did we want to find the answer to the nearest degree? So 16.71 nearest degree is going to be 17 degrees. Bearing in mind that's not our answer. So I can now say, what colour did I do that green? That was what that was in. So I can now say that therefore the angle of elevation and how does it say it in the question? From M to K is, we've got, it was 75 degrees minus the 17 degrees that we just put down, which is going to be 75 minus 17. My brain's a bit fried at the moment. I should be able to do that. But I'm going to just use my calculator because I'm lazy. 75 minus 17 gets me 58 degrees. Okay, so there we are. We've answered the question. Just make sure you've answered the final question, and we have, so we'll move on. Okay, the next one's a little bit more stepped out, and it's probably easy to get a little bit confused if you don't pay attention to what's going on here, but the very first thing I would point out is that this here is a straight line. So finding alpha should be very, very easy. There's 180 degrees in the straight line. So that angle alpha equals 180 degrees minus 31 degrees. So that's going to be 149 degrees. And beta is going to equal 180 degrees because there's 180 degrees in a triangle. We now know what angle alpha is. We know what this other angle is. So we know all the angles in that triangle once we do this calculation. So 180 minus 18 degrees minus 149 degrees. For that, I will use the calculator again. So 180 minus 18 minus 149 gets me 13 degrees. Okay, so that's part A done. I'll move now on to part B. Now for part B, it says use the sine rule in triangle ABC, so that's that top triangle, to find x to correct to 3 decimal places. So obviously I'm looking for pairs of matching distances and angles. So there's a pattern matching distance and angle, and there's a matching distance and angle. So there's my pairs, and only one of them is not known because I already know what beta is. We just worked that out in part A. So the thing that I want to know, I put at the top. So in this particular case, I'm going to say x over sine 18 degrees equals now 72 over sine 13 degrees. Okay, and if I multiply both sides by sine 18 degrees, then those two are going to cancel out on this side, and I'm going to be just left with x equals 72 on sine 13 degrees times by sine 18 degrees. And I plug that into my calculator. 72 on sine 13 degrees times by sine 18 degrees. And that's going to give me 98.9. The question has asked for me to give it to 3 decimal places, so 98.907. And the answer is going to be in centimetres. And we're still not finished because there is a part C. And for part C, it's hence use triangle ACD to find the value of h. Now, there's a bit of a mistake here. That should say h. Correct to 1 decimal place. Now that I know this distance in here, now that I know what x is, and I've got so in this particular triangle, I've got an angle, I've got a distance, and I want to know another distance, so I can just use basic right angle triangle trigonometry. In this particular case, with reference to that angle, we've got an opposite side and we've got a hypotenuse. So when we've got the opposite over the hypotenuse, that's time for sine. So sine theta equals the opposite over the hypotenuse. Now in this case, I know what the angle is. The angle is 31 degrees. The opposite side is h, that's the bit I don't know. And the hypotenuse we just worked out was 98.907. So we multiply both sides by 98.907. And we're going to wind up with h equals 98.907 multiplied by sine 31 degrees. Now, if I'm lucky, that should still be in my calculator, and it is. So I just take that number and I multiply that by sine 31, and that will give me my answer. And it asked me, in this particular case, it asked me to 1 decimal place, so that's going to be 50.9 centimetres. And so there we have it. We've got through all of those last all of those questions. So there is a couple more questions to go in this particular section. I'll do a second video and I will see you there.